Right, Stephen?
Great. Well, good morning, everybody, and thank you so much for joining. I appreciate you all taking a little bit of time out of your day to join us here at the ACT-IAC Networks and Telecommunications Community of Interest, our second event for this specific working group. But what I would like to do first is just remind folks that are returning, and then let folks know who perhaps are new to ACT-IAC what we're all about. So ACT-IAC is a unique organization, and that it facilitates the engagement of government and industry to collaborate and advance the mission of government. And within the networks and telecommunications community of interest, we're obviously focused on providing impartial feedback, analysis, recommendations to the government on all things networks and telecommunication related. So by way of introduction, my name is Stephen Matherne. I'm the Industry Vice Chair for the Networks and Telecommunications Community of Interest. And I will invite you all who are joining to continue to participate in ACT-IAC. So we're obviously going to talk a little bit about the Modernizing Federal Networks project and working group. But I would also bring to your attention some things that are coming up on the calendar for ACT-IAC, and specifically with the Networks and Telecommunications Community of Interest. So on June 16th, from 10 to 11 a.m., our Community of Interest will be hosting an in-person and online panel session related to the EIS project. So there is an ongoing project to support recommendations to GSA relative to the next generation of EIS. And if that's something you're interested in, I would encourage you to join and participate. A reminder that is coming up on June 16th. For that session, as well as other information related to ACT-IAC and the Networks and Telecommunications Community of Interest, I would direct you all to the website. And there you can sign up. You can engage with the N&T COI, as we like to say. And I'd remind you all that this is a volunteer organization. So the success of ACT-IAC is underpinned by folks who are willing to raise their hand, volunteer their time to support this incredibly important mission. So thanks so much for joining today. And I'm optimistic that we'll see you all in future sessions or in future projects to support the mission of advancing networks and telecommunications within the government enterprise. For today's session, I'd like to first do some quick introductions. So we have an esteemed panel with us, and many are returning. So I would remind folks this is our second session, which is really the introduction of the deliverable. That is the white paper, the documentation around how agencies might consider and think about modernizing their federal networks. And the panelists, I will introduce you, and if you could spend just a few moments talking about what you do, and then we'll get into the actual discussion. So Erik, if you wouldn't mind kicking us off. Erik Hand.
Yeah, great. Thanks, Stephen. Good morning, everybody. My name is Erik Hand. I have been with AT&T for 19 years now in various technical roles supporting FedGov. Today, I lead AT&T's federal sales engineers and architects supporting our national security accounts.
Thanks, Erik. Mohamed Hersi.
Yes, thank you, Stephen. My name is Mohamed Hersi. I'm with ACI Solutions. I am Chief Security and Strategy Officer for the company, working with innovative technologies across the platform. I'm also the co-founder of ACI, been there for over 24 years.
Thanks, Mohamed. Okay, moving on to Joseph Tahan.
Tahan with Charter Communication, Spectrum Business, Federal Business Unit. I lead the BD and capture, working with our customer and client on solving telecom challenges.
Great.
Thanks, all Joseph. My career.
All right. Scott Andersen.
My name is Scott Andersen. I'm a solution architect designing network solutions for the federal government.
Thanks, Scott. Mr. Phil Moser.
Yeah, Phil Moser. I'm with Fortinet Federal. Been there
a couple days out over 7 years, and I manage the civilian agency programs for Fortinet Federal.
Thanks, Phil. Okay, last and certainly not least, Mr. Chris Grindstaff.
Yeah, good morning, everyone. My name is Chris Grindstaff. I'm with AT&T Federal, and I lead a team of engineers supporting our federal civilian accounts.
Excellent. So, gentlemen, thank you so much for volunteering your time to participate in the development and delivery of this important project. And modernizing federal networks is, you know, as we've discussed internally a bunch, it's a journey, right? In many ways, seemingly a never-ending journey, but one with new topics, new areas of focus. And I think we're going to get into lots of the areas of focus, these landmarks along the journey. You know, I think we'll talk to things such as AI. Certainly AI is around us in the press all the time. I think we'll also talk about things like quantum, you know, how that could impact our environment. And then we'll talk about, you know, this future agile state. And, you know, for those of you who are invested in this journey, and I encourage everyone to take a look at the final documentation and deliverables, I think what you'll understand is we've characterized a future agile state is really the panacea for federal networks and something that they should hold as their North Star on their modernization journey. But before we get into that, what I'd like to do is maybe kick things off by talking a bit about the current state, you know, where we are broadly within the federal enterprise environment. So, Joseph, why don't I hand it to you first to get us started?
Thank you, Stephen. And I want to thank you for your leadership on this project. I really valued the collaboration and insight that we gained working together on this effort. So the current state, we still see significant amount of MPLS TDM technology in the field today. It is like your old car, has sentimental value. It's reliable. It gets you from point A to point B. You rigged your phone to the dashboard for GPS and entertainment, but you would not, you know, take your whole family on a cross-country road trip in it. So it's just not built for the long haul. So we see the transition from this architecture that was rooted in MPLS, TDM, and private line, which is reliable connectivity across the agencies and mission-critical environment. We have spent 20 plus years perfecting that architecture. It's a perimeter-based defense system. It is an architecture defined by standardized configuration, and centralized authority is a model that was designed for a different era of connectivity. The landscape is shifting irreversibly, either by mandate, evolving technology, or, as you indicated, demand for agility and efficiency. So today, federal missions depends on cloud-hosted services, mobile-first workforce, and data-intensive platforms such as artificial intelligence, analytics, real-time sensor fusion. So the federal network is starting to embed zero trust principles into the very fabric, continuous validating users, devices, and application. So zero trust is a topic that is kind of difficult to discuss at home. The other day, I text my wife asking her when she'll be home, and she sent back a message: please identify yourself, provide the device you're using, the secret code, and your location. I text back, I'll see you when you get home. Security is no longer a bolt-on. It is intrinsic to the design. Continuous monitoring, real-time compliance validation, and automated remediation by artificial intelligence are ways to keep pace with evolving threat. So I'm going to transition to Chris to discuss mop-up of TDM transition at this point.
Yeah, I think I'm going to let Mohamed, he was prepared to talk about that. Please,
No worries, no worries.
No,
Thank you so much, Chris. No, I appreciate that. And absolutely, you're right, Joseph. You know, one of the things that we discovered during the development of this document is that how far along agencies are in that TDM legacy migration. And unfortunately, some number of those agencies are still making that transition today. And these decisions were made when the world's a lot more predictable. The data was more centralized, applications were more centralized, agencies control their data centers and the reliability on voice infrastructure that relied on the PBX infrastructure. So one of the pillars of the modern future agile network is the stability and functionality, and to build towards that architecture that is a cloud native architecture that supports AI-driven workload. The distributed edge computing incorporates cyber resiliency and defense. And those are things, unfortunately, right now, TDM legacy circuits are incompatible with and delay the adoption. So one of the things that I want to share with everyone today is at this level one of the modernization of the future agile network, the work is going to be a lot harder and it's going to require a lot more intensive, and it's a lot more rigorous than we give credit for. The challenge that isn't awareness that agency leaders are facing today. The challenge is that, TDM, mop up is just very difficult thing to do. Every remaining TDM circuit represents its own dependency, whether it's that PBX legacy integration, analog devices that are connecting to elevator systems, or video cameras or alarm systems. Sometimes mission critical voice infrastructure that cannot tolerate an outage during the transition. So in some of those locations, unfortunately, there's no alternative to TDM, which means that we're going to need to rely on GEO, LEO, MEO type of satellite services. And this is something we're going to talk about on this call today. So to add to this complexity, unfortunately, some of these circuits were purchased through legacy contracts that have since expired. Agencies have made direct purchase agreements, and retiring them without a plan usually leads to financial penalties, and it creates operational risk. So what's the takeaway for us today on this call is to understand that this transition must continue to occur. I encourage all leaders and industry leaders to continue to push that retirement to completion. Deferring this mop-up will continue to create for an agency a technical debt, and it will delay the modernization and adoption of security infrastructure into your environment and introduce operational risk. And to address some of this risk, I want to go ahead and pass it along to my colleague Chris, who was going to talk about the TIC architecture, which is one of the things that we decided that the agencies came up with in the past. Hey, to you, Chris.
Thank you, Mohamed. Yeah, I just want to set a little historical context for the current state of the network that Joseph and Mohamed were talking about, and kind of where we are right now and how we got here. So in the past, the security posture was all about reducing the security perimeter. Therefore, the TIC, your Trusted Internet Connection 2.0 guidance, focused on protecting the enterprise through centralized network access points. So centralizing and having just a few internet access points to a otherwise private network architecture. The model was based on the idea that agencies could control and inspect the traffic at these defined perimeter locations, and they could improve visibility and risk, and that worked. However, this was more effective with those traditional network architectures that we've been speaking about, and has become harder over time as users adopt applications that moved outside the traditional perimeter. Over time, agencies and their users began to rely much more heavily on cloud services, software as a service platforms, mobile computing, and telework. And something I learned, and I knew in my head that these things all kind of came together at the same time, but it's interesting to think about the confluence of events that occurred roughly around the end of 2019 and early 2020. And I think we all remember what was going on then. But in September of 2019, OMB released a memorandum outlining the TIC 3.0 initiative. And in December of that same year, CISA released the initial TIC 3.0 guidance. Well, in January of 2020, as I'm sure most of us recall, we had the first confirmed case of COVID in the United States, which eventually led to large-scale lockdowns and huge increases of remote workers across the country that obviously included federal workers as well. And this all occurred by mid-March of 2020. And in July, CISA released their finalized core initial TIC 3.0 documentation. So all of those things kind of accelerated this move away from more traditional network architectures. And I'm going to turn it over to Erik now to talk a little more in depth about what TIC 3.0 did and how it opened up the possibilities for networks.
Yeah, thanks, Chris. So we have this new TIC 3.0 guidance, and federal telecom leaders everywhere are asking themselves, will TIC 3.0 drive better outcomes for my agency? And if so, where am I going to see these improved outcomes? So first and foremost, as agencies adopt TIC 3.0, they'll see reduced future tech debt in their TICs. The TICs are the most expensive elements of our federal networks today, where we have all of our cybersecurity investments in terms of firewalls, IDSs, IPSs, AV, DLP, reverse proxy, forward proxy, PCAP, et cetera. Very, very expensive. As agencies shift to a TIC 3.0 architecture, you can see reduced future tech debt in those TICs. As you extend internet circuits to your branch offices, you'll also see enhanced application performance and potentially enhanced visibility on cyber events as well through your FedRAMP Secure Web gateways. So how do we come up with this savings? If you compare FedRAMP SSE licensing plus management to today's MTIPS costs, there's a clear 50% savings per megabit per second through that FedRAMP SSE. So MTIPS is 2x the cost of an SSE architecture. And if you look at custom agency managed TICs, that multiplier is going to be even larger. Okay, so right there, it's very clear that we can save money by adopting a TIC 3.0 architecture, extending internet connectivity to branch offices, and establishing encrypted tunnels from those branch offices to our secure web gateways to get our applications and our end users closer together. So how does it improve performance beyond that? Legacy TICs often serve as network bottlenecks today as well. We're basically backhauling all of our traffic to the internet to either an East Coast or a West Coast TIC across most of our federal agencies. By backhauling all that traffic, there's a potential bottleneck. As traffic goes through your various firewalls, IDSs, IPSs, there could be additional latency. Again, by moving this traffic down to the field office or allowing it to enter the internet from those locations, you're going to reduce those bottlenecks and improve performance. Okay, so now that we've decided to adopt a FedRAMP SSE to offload our internet traffic, we have those internet circuits there, we can't just stop at that point. We also should layer on SD-WAN to enhance site resiliency. SD-WAN is going to allow us to take our legacy WAN connectivity that was likely MPLS and add on internet connectivity as underlay and enhance resiliency. You wouldn't just route all your traffic to a FedRAMP SSE. You would maintain your WAN now in an SD-WAN state to continue to modernize and adopt that agile network we're talking about. To go more into SD-WAN and SASE, I'm going to invite Phil and Chris to discuss.
Thanks, Erik. Yeah, so as Erik mentioned, those traditional WAN models were designed for different traffic patterns than what we're seeing primarily today. So in many environments, it was essentially just a hub and spoke, where a branch primarily connected back to a core data center or hub where applications and those security controls resided. And in that environment, MPLS, layer 2 VPNs, and private lines were quite effective in providing reliable connectivity, but they were built around fixed paths, often had long provisioning cycles, and relatively static traffic patterns. So as Erik mentioned today, that model is under pressure because users are increasingly accessing software as a service applications, cloud platforms. They're more mobile users, and they need internet-based services accessed directly without having to go through that centralized TIC. As a result of backhauling traffic through those centralized locations, as Erik said, you can create unnecessary latency, complexity costs, but those bottlenecks that he spoke about. But SD-WAN changes the way the WAN is managed and optimized. Instead of relying primarily on a fixed network path, i.e. MPLS or private lines and manual configurations, SD-WAN introduces centralized control and policy-based routing and real-time path selection. So in the legacy model, premium private connectivity often served as the default solution for most traffic. I think, you know, how you would treat your voice traffic today. That's basically how all the traffic was treated in the past. But in the SD-WAN model, different types of traffic can be treated differently. Business critical applications can be prioritized to be sent over the best performing path, maybe with low latency, jitter, or packet loss, while less sensitive traffic can use lower cost links such as broadband internet. And as Erik mentioned, the introduction of these lower cost underlay transports can offer significant cost savings. In addition to that, agencies can realize cost savings through operational efficiencies, through increased flexibility when it comes to hardware, licensing, and engineering resources. But it's important to note that moving to SD-WAN is not only a networking decision, it also affects the security architecture. Introducing internet at the remote branch locations as opposed to the traditional centralized TIC increases the security perimeter of the network, obviously. And as the traffic becomes more internet-based and distributed, security controls must evolve as well. And that's what Phil's going to talk about next, is how we can evolve those security controls in the new SD-WAN environment.
Great, thanks, Chris. I appreciate it. So I'm going to talk a little bit about these two different streams that are coming together. One of the evolution of the security controls from TIC 2.0 to TIC 3.0. And then what Chris referenced in terms of the evolution, adoption, increasing adoption of SD-WAN into the federal agencies. So, and a lot of the themes that are driving this, Chris and Erik and others have already laid out in significant detail. But a lot of what's driving it is really the ability to decentralize both the security controls and then leverage technologies like SD-WAN to be able to provide flexibility and resiliency and redundancy into that network. And it does enable agencies to, as Chris and others have indicated already, to enable direct internet access. This becomes increasingly important as more and more SaaS applications form the backbone of mission critical requirements. So just one example, one of the very large organizations that we're aware of, when they started looking at where their traffic patterns were going, they found that 60% of their traffic was actually going to one SaaS instance, a pretty ubiquitous instance, across the network. Well, that raises some interesting questions. So instead of 60% of traffic having to go through a centralized TIC and out to the SaaS cloud provider and then back, what value would there be if you could just go directly to that SaaS cloud provider, that SaaS application? So that raises a lot of opportunities, particularly as TIC 3.0 becomes more embedded in their different ways to access the WAN. The challenge is that system security controls still need to be in place. And that's where TIC 3.0 becomes a really, really nice alignment to the emergence of SD-WAN and the ability to go directly to internet applications where it makes sense. So at the same time that you have this confluence of events and technology trends, you have vendors that are increasingly converging security and networking into their solutions. So particularly at the edge or in cloud applications. So you have the ability to provide at the edge of the network, for example, SD-WAN and security controls, all from a single platform and all from a single product. So what this allows actually is for security controls to be placed across the network where it's most efficient for that particular agency and where it makes most sense for that particular agency. Provides a lot of flexibility. And these security controls, which we call PEPs or policy enforcement points, those can be placed at the edge of the network. They can be placed at internet exchange points. They can be placed at the edge of the cloud, or they can still retain their role in a TIC or in an MTIPS environment. But the key point here is that the agency engineers and architects now have the ability, both because of technology as well as policy, to be able to put those PEPs where it's most efficient and where it makes more sense for the particular agency. SD-WAN is the key component of that, but that also opens up the possibility of SASE, which is not to be confused with SaaS. But in the SASE environment, those controls and both the networking as well as the security controls now are centralized and centrally orchestrated through a SaaS provider, either through, that are being hosted in a public cloud or a SaaS provided cloud. Especially important for large remote workers, smaller agencies that have a smaller staff. All of that now can be centrally managed and driven from a SASE cloud provider. So it's really kind of exciting, pretty interesting to see how both the evolution of networking technology and policy and technology prescriptions on the security side are coming together to really provide a lot of additional options to agencies as they look to modernize their network. With that, I'm actually going to turn it over back to Erik, who's going to talk about some of the other ways that SD-WAN can leverage what heretofore have been sort of niche WAN technologies that now are becoming, part of the core WAN architecture for a lot of agencies.
Yeah, thanks, Phil. So exactly, when we talk about SD-WAN, we need to talk about the actual technologies we're using to connect to the network. I think we would all love for all of our offices and field sites to connect back to the WAN via fiber, but economically that just does not make sense everywhere. Today we have a lot of TDM circuits that are still out there supporting our customers and in many cases our remote sites, and those TDM circuits are going away. And a lot of our WAN providers are not replacing those TDM circuits with fiber because, again, just does not make economical sense. Special construction to deliver those circuits might be in the millions of dollars, and no one wants to pay for that for a single connection. So instead, we need to look to things like our non-terrestrial options like satellite. Historically, satellite has been geostationary and medium Earth orbit satellite constellations that we work with. Geostationary is up there at about 35 kilometers above the Earth's surface, whereas medium Earth orbit's about 8,000 to 20,000 kilometers. Those have been two very great constellations supporting us in those hard-to-reach locations, but there are drawbacks in terms of latency and also in terms of costs. The cost to use the spectrum supporting those satellite networks, very, very expensive. Today, we now have some low Earth orbit satellite options. Low Earth orbit satellites are above the Earth's surface at about 500 to 1,500 kilometers. That means that latency is far reduced for all connections over these satellites. And the constellations themselves are also far more dense, okay? With a LEO option, we can now, at a low cost, replace some of those legacy TDM connections out in places that are very hard to reach, like Alaska, which are maybe dependent upon, again, TDM that's going away or a more expensive geostationary connection. So just adding LEO into our toolkit of ways to connect our field office sites is a great way to support that agile network that we're talking about and that we're moving toward here in our paper. So please keep that in mind, especially as you're going and ripping out your TDM connections everywhere. Okay. And now I'd like to invite Joseph to talk more about multi-cloud connectivity and unified policy control in the context of this agile network we're moving towards.
Thanks, Erik. Right. So as a result of the discussion, really what we're saying, the reality of the new parameter, the federal data is no longer in one location, in one single data centers. It lives on premise, tactical edge, or multi-CSPs from AWS, Azure, Google, Oracle, and other, as Phil indicated, SASE application. We're really going toward a unique applications. But also, let's not forget, data centers in the sky, in space, where we can leverage LEO and MEO to get to them. So managing that fragmented security, rules and manual routing across these silos created vulnerability and shadow ITs, as many of you might have heard. So really, how do we do this? The solution is to define a unified network fabric. And as we said, leveraging SD-WAN or SDN to treat desperate transport, as we discussed, the fiber, the broadband, 5G, LEO, MEO, as a single logical network, replacing that single path with diversity, high-speed cloud connectivity, and ensuring resiliency, flexibility, and low cost, as we shared with you. So that single pane of glass is significantly improved, shifting from a location-based rule to a zero trusted policy that follow the user of the application regardless of where they sit. The same security posture, as we indicated, at a regional headquarters can be mirrored easily to a remote field site. So then the automation of moving beyond manual box-by-box management. Now we can push security, update, and routing changes to 100+ sites simultaneously. Or we could do controlled wave, some of you have heard, wave of locations, with automation for automatic rollback and restoration in the case of changes that did not work well for you. So therefore, we're talking about agility, the ability to spin up new cloud workload, edge site, or VNFs in minutes, not weeks, through automation and provisioning. Resiliency, intelligent path selection, ensuring mission-critical traffic automatically rerouted if a data center or a circuit fails. So the automation and the flexibility are limitless when leveraging SDN across the WAN. So now I'm going to transition to back to Mo, to discuss AI ops. So Mo?
I appreciate that, Joseph. So now we've introduced MPLS, SD-WAN, SASE, Zero Trust, multiple different FedRAMP, high cloud service providers, LEO, GEO, all of these different technologies into the environment to create this future agile network that's robust and resilient. So we need to be able to have a way for us to be able to have visibility across that network and resiliency as well. So AI ops, digital resiliency will serve as the core of the operational intelligence for the future agile network. One of the things that I wanted to try to unpack is to try to understand how agencies today that we work with are striving to have visibility, resiliency, availability across the network. And as the intelligent layer of the future agile network and modernized future agile network to that end, AI ops and machine learning automates those anomaly detection, predicts failures, and dynamically optimizes routing across the network, as Joseph mentioned. We're building this into the architecture, and now we need to have the ability to have visibility across the network. So with visibility, AI ops platforms are ingesting large amount of data, telemetry data across the infrastructure, across multiple domains simultaneously, looking at application performances, looking at user experiences, the infrastructure health, traffic flows, BGP routes in real time, and trying to make a decision that's going to go ahead and allow users to be able to get to the applications, those mission critical applications, and those agency applications that you need to be able to do your job quickly and in that, again, multi-domain, multi-cloud enterprise. And with that, we want to be able to make sure that we have resiliency across the network. And as Joseph mentioned, as we build this architecture, the path, the intent is to build a network that's intelligent, that's rather active than passive. It doesn't have to wait for circuit failover. We want to be able to trigger alerts. It detects, AI ops will detect service degradation before failures occur, predict where capacity is constrained, and automatically steer traffic to the path that's best available for the user. And that's going to lead to availability. And with availability, it's not just an IT metric, and that's something we talk about, MTTR, MTT, mean time to correct. Availability is a mission critical metric that agencies need to look at. They want to be able to reduce that time that it takes to identify an issue and repair. Having AI ops in the environment reduces that. It allows operators to stop spending hours or trying to triage issues. The system automatically isolates those issues creates identifies those faults, correlates it to a cause, kind of creates a MOM architecture that allows the remediation to occur, and sometimes it does those remediation automatically within governance guidelines. So lastly, one of the things I want to touch on is security. Is that collaboration that needs to occur between the NOC and the SOC. As we look at all these different telemetry data from all the different environments that AI Ops is looking at from an operational standpoint, those same data is going into the SOC environment. And that's providing a real-time awareness across the network. So it's extremely important for those two different organizations to work closely together to be able to look at issues that are operationally impacting the network, are not security related, and vice versa. So to talk more about cyber defense and in the world of AI, I want to turn it over to Phil, and on to you, Phil.
All right, thanks, Mo. I appreciate it. A very good description of how AI is helping on the SOC and the NOC and AI in operations. So I'm not going to cover a lot of that, but that is a key component of what AI is driving towards right now. I did want to take a little bit of a step back, though, first, and just highlight the fact that AI and machine learning has been part of the cyber world for quite a while. Similar to way AI and machine and ML is part of your Google Maps or your Waze or however you figure out a way to get around the Beltway every single day. What would we all do without those capabilities right now? In a very similar way, AI and machine learning has been part of cyber for a long time in helping to be able to very rapidly identify threats and then be able to provide guidance in terms of for humans that are managing the network in terms of what to do with those identified potential threats. What's changed here on the network side is the scale of networking and the adaptability and flexibility of networking. So it's great to have flexibility and adaptability, but with that, we have to be able to respond very, very fast on the cyber side to protect that data. And similarly, as networks scale rapidly, and you're going to hear a little bit more about that in terms of what's driving the expansion of the networks. We've got to have the cyber infrastructure in place to be able to process huge volumes of traffic and to be able to inspect that traffic very, very quickly. So this is where AI comes in. In terms of the cyber capabilities, there's really 3 or 4 things that this new, I'm not going to say it's new AI, but it's really the acceleration of AI across almost every aspect of our work in personal lives. It really affects cyber in 3 or 4 different ways. One is speed, how fast we can respond to anomalies that are detected, whether they're malicious anomalies or not. But the speed is extremely important as this new agile network gets rolled out. Second is scalability, being able to, again, manage and inspect elephant flows, for example. And the scalability goes up and out. And AI and machine learning and the capabilities that are associated with that allow us to do that, again, very, very rapidly. The third component I classify as predictive capabilities. In other words, using AI to predict traffic patterns and to rapidly identify what looks like suspicious activity, and to be able to take almost real time, in fact, it is real time decisions based upon suspicious activity, whether that gets quarantined, whether that gets passed through after a very quick analysis from the machines in terms of whether that's malicious or not. But that predictive capability is super important. So when security systems are put into a network, with AI now, we're beginning to learn those security systems learn the traffic patterns, the signatures, the types of people that should be accessing what types of applications. All that now becomes ingested into the machines and the IA and the AI capabilities of cyber systems. And then once that's done, and the more you learn about traffic patterns and behavior, it's almost like behavioral analysis for networks and security. The more that the more that system learns about the behavior of that traffic pattern, the faster it's going to be able to respond to potential anomalies. And then once it sees something, it can leverage what Mo was talking about in terms of the automation that comes with AI. And that's a lot of what we're seeing right now. And a lot of the excitement is to be able to take that machine learning, translate that into AI ops, and really relieve the humans that have been staring, at these screens for years and years, and give them very concrete data very rapidly in order to be able to make some decisions of what to do with that traffic. So with that, I know we're probably running against the clock a little bit. I'm going to turn it over to Scott, who's going to talk about the impact of AI and machine learning on networks, and then the future agile network.
Thanks, Phil. So first of all, I want to be really clear. There's a reason that we chose the name Future Agile Network. It has three components. Future is tomorrow. Agile, we're all familiar with. That means not only a development model that everybody knows and uses, but Agile also means able to respond to pressure. And network, because network is the future, which is kind of funny if you think about it. Once upon a time, networks weren't the future, then networks became the future, then they weren't the future, then the internet came, and now we don't think about networks anymore. We just use them all day, every day. But that network is a critical component of how the organization moves forward. And there are a couple of component things to consider as we look at the future. One is, and it comes out of the 5G world, it's called SON, or self-organizing networks. And a self-organizing network is basically able to respond to both bandwidth, environmental, and capacity changes in a very rapid manner. It's able to move things around. You'll hear things like network slicing thrown out, where I can take a network and break it up into dedicated pieces, and each of those dedicated pieces is dedicated to a section. But because it's a self-organizing network, the network will respond and be able to change rapidly as that traffic changes. The other component is what's called IBN, or intent-based networking. And now you've heard Phil and Mohamed talk about how AI is going to be there. You heard Chris and Erik talk about TIC and the evolution of TIC and what does that look like? Well, IBN is that next step. So Phil mentioned the fact that, you've got this concept of AI doing things. Well, let's think about, the network operations center of, I don't know, let's say the year 2015. Actually, let's take it back a little further. Let's take it back to 2008. In 2008, the internet was big, but we didn't have a lot of cloud computers. We didn't have a lot of cloud computing. We didn't have a lot of cloud providers. We had the initial nascent, right? The various distributed data center systems were up and running, but there really weren't cloud providers. What did cloud providers do? Cloud providers provided a single instance for security attacks. So all of a sudden you had Amazon, Microsoft, Google, and others no longer participating in security the way everybody else was. They were facing 1 million, 2 million, 3 million attacks every day. And that's a difference, and that's the evolution. Well, enter AI. And what does AI do? Well, AI takes a look at 3 million incidents occurring in a day, leans back, yawns, and says, "Is that all you got? Really? I mean, that's not that much. You're really not scaring me." In fact, AI can handle tens of billions of attacks in a day. Now you suddenly have a network that is aware. It is able to respond. Imagine, and I'm not saying this is real, this is imaginary, this is out of Scott's head, so, please be aware. But imagine a point in the future where the network gets attacked. And the network reaches its hand through the network, grabs the hacker around the throat, squeezes a little bit, and says, no, don't do that. Right? I mean, networks of the future that are able to respond to a hacker directly, they're going to be more powerful. They're going to be better. But the other side of IBN, or intent-based networking, is once you have that AI infrastructure in place, you can begin to do true effective routing within an organizational network. You can begin to actually on the fly route and structure and build all of this. And the reality is, and the reason for this, and the reason that this is going to be so valuable is the other side of AI. Because we've talked about AI and the network, we've talked about AI and security, but don't forget, there's AI for the knowledge worker who's sitting there typing into OpenAI or Google, create an image. And if you download our white paper, you'll notice that there are images in the white paper, all of which were created by AI. So create an image of X. Knowledge workers are going to start using AI. So now you have users using AI, you have security consuming AI, and you have operations consuming AI, all of that in a single unified network, able to provide resources and adequate structure and adequate infrastructure so that as we go forward, all of these things will deliver that future agile network of tomorrow.
Hey, Scott. So there's no question that AI is incredibly powerful today, right? And I think you're doing a good job of highlighting how it could evolve in future state, to including, AI-enabled networks biting back a little bit on the security side, right? The other area of real interest, and I think that's kind of on the emerging side, and I think we're all waiting with bated breath for, Q day, right, is quantum, right? And so I wonder, I don't know if you want to talk just a little bit about, quantum, PQC, and what that
about and posturing our networks for a time at which today's crypto keys are no longer doing their jobs. So the WAN is where the data leaves our physical buildings, and we no longer have control of exactly what happens to it. We trust our WAN providers. We trust, in some cases now, the internet to get our traffic where we expect it to go. And this is where we're most subject to man-in-the-middle attacks and data harvesting. So today, data harvesting is happening already. Our adversaries are doing things like advertising networks they do not own and routing our traffic through their countries where they control network infrastructure, and they're harvesting. This happened many times between 2010 and today. So with that in mind, agencies should be looking at solutions that can provide quantum-resistant cryptography on their edge appliances. And there are vendors out there today that can do that in a very seamless fashion. And instead of setting and forgetting those crypto-resistant keys, we can rotate them at much smaller intervals. That smaller interval will make sure that if a key is compromised, our adversaries get much less data that they have access to. So again, PQC vendors can support this in conjunction with your existing edge hardware and do it in a seamless way, compressing those key rotation intervals. Number two, the second thing I want to bring up is that in the age of quantum computing and a threat to our cryptography, should agencies be considering retaining some of their private network infrastructure? Instead of going all in on using the internet as an underlay, maybe it makes sense to definitely take advantage of the internet as a lower cost underlay and its flexibility, its agility, but hang on to some private network infrastructure for our most critical data flows. So that's something we discuss more in our paper. I'll just tease it out here today, but please do read. And I think it can help you think about what this threat really is.
Yeah. Thanks, Erik. Appreciate it. And another area that's really interesting from the AI, and certainly within the federal environment, is tactical, right? So we talked a little bit about the edge, but we didn't talk tactical at all. Joseph, I don't know if you want to talk about things that are happening in the edge and the tactical space at all.
Yeah, that's perfect. Yeah, I think we touched on it, and so when we thought about migrating from a single data centers on-prem to the cloud, as the team have indicated. We thought the shift is going to be continuously moving to the cloud. But really today, I think what we're talking about, the network is distributed, is alive across, and edge compute for tactical decision making, which is the brain of the network where a decision is happening, is really moving back to the edge. The edge could be a mini data centers, a drone, a sensor, soldier wearable, robots, etc. All of that data is really happening and being processed right at the collection point. With very little data, the chutes are sent back to the command and control centers, back to the cloud. So a lot of that, I know we're running out of time, but really think about your network and where your data is distributed, the edge now becoming really the smart, the intelligence, the real-time tactical decision-making is really happening at the edge. So it's covered in the paper, and we appreciate if you have any questions or future discussion to have with you. Back to you, Stephen.
Thanks so much, Joseph. So for everyone who's joined us, I do want to invite you. We have about 7 minutes remaining, but at this point in time, if you have questions, if you wouldn't mind dropping them in the chat over the next minute or two, and we'll save just a few minutes at the end for questions. But Scott, perhaps while folks think about questions, if you want to kind of wrap things up a little bit relative to the AI fabric data and how the human machine governance model influences this future agile network state.
Absolutely. I'll try to keep it really short. The concept of fabric is very simple. The reality of data is data doesn't live in central stores. I was a knowledge management guy in the 90s and 2000s. We tried to do that. It doesn't work. And the reason it doesn't work is that IP is created on the edges. As Joseph was just pointing out, we now have these secure, powerful edges. And so data gets created there. And when you move data into the core, you immediately make it obsolete, right? Because the person that created that IP is now iterating and creating a new version of it. And so you create this immediate problem of you don't have the best data available at the right time. Or to steal from Mr. Gates many years ago, the right data at the right place to the right person to make a solid decision. So when we think about that, that is what the fabric is. Ubiquitous connectivity. Erik talked about LEO, GEO, MEO, all the satellite connectivity, the unified ability now to do a cellular, a satellite, an MPLS, an SD-WAN, all of those connections coming together in a unified manner to provide that high-level view. And then, of course, the reality of the word governance, it's a scary thing. In the AI world, everybody always says guardrails, and I always snicker when somebody says guardrail to me, because a guardrail is simply an accident that's preventing a catastrophe. So a guardrail is a bad thing. You don't want guardrails. You want to have governance that responds long before a guardrail is needed, right? Because you think about where are guardrails on the side of a road. They're on the side of a cliff. You hit the guardrail. Yeah, okay, you didn't go over the cliff, but you had to hit the guardrail. So the reality is we want to have governance that is integrated, that is part of the future agile network, that becomes a deliverable component that the agency can take advantage of, can grow, because ultimately, on a maturity model basis, when we consider the value proposition of getting to a future agile network, you're able to respond to the changes that your network requires. And I'll pass it back to you, Stephen, for any questions.
Great. Thanks so much, Scott. I love it. Guardrails are accidents that prevent catastrophe. I think that's one I'll add to my repertoire. So, gentlemen, thanks so very much for spending time this morning, talking about the work that we've undertaken. The good news is the discussion has been fairly comprehensive because I don't see any questions from the audience right now. So I will invite folks who are participating online, invite folks that perhaps listen to this in a replay to please take a look at the ACT-IAC website. Within the Networks and Telecommunications COI section, you will see this Modernizing Federal Networks from the Campus and Beyond deliverable published. I hope that you will take some time to download, give it a read, digest, and provide feedback. And what I mean by that is get engaged. Back to my earlier conversation, you know, ACT-IAC facilitates engagement, right, between industry and government and across the two. And that's predicated upon folks volunteering and engaging to participate. So, gents, thanks so very, very much for your time this morning. For those of you who've dialed in to listen in, thank you for your time. I look forward to a lively discussion, perhaps on the as we follow up on the deliverable and future engagement from all parties. Thanks so much. Have a wonderful rest of the day.
Thank you, everyone.
Thanks, everybody.
Thank you.